Good day, my schoolers. This is my school channel and my name is Abiola. For this video lesson, you'll be joining me to solve the JAMB CBT past question for the subject chemistry, the year 2009. Do not go anywhere. Stay with us and we'll be right back. Welcome back to my school YouTube channel. Right there, you are going to join me to tackle questions 26 to 50. So join me as I begin with question 26. In the diagram above, which of the curves represents the evolution of oxygen with time in the equation? Okay, so right here we have potassium trioxochlorate 5. So if you recall the lab preparation of oxygen, you know you can break up the decomposition of this or the composition of H2O2, hydrogen peroxide, or you can also refer to oxidation of hydrogen peroxide. For this particular equation, you know that even at high temperature, okay, this will slowly decompose to release oxygen. What can we do? In the presence of manganese 4 oxide catalyst, the reaction will occur at a lower temperature and at a much faster rate. Okay, so if you now go back to the rate of reaction, you realize the effect of a catalyst. All right, this typical diagram reveals that the presence of the catalyst actually makes this particular reaction more viable. Okay, so you can look at this. So this is actually what represents, this is the curve that represents the reaction that we are hunting for. So in diagram above, which of the curves represents the evolution of oxygen with time in the equation? This is it here. So the correct option is option D for curve R. Question 27. A catalyst increases the rate of a chemical reaction by providing a path that does what? Okay, a path that lowers the activation energy. You can take, for instance, a positive catalyst. You know, what's going to do is that it's going to lower the energy barrier. Or you can put it in other words that a catalyst, right, for you to increase the reaction rate, what it's going to do is that it's going to create a new reaction path, okay, with lower activation energy. So this is what we have. The option C is the correct option. Question 28. We have copper 2 oxide plus hydrogen gas. You have copper, then water. Okay, so what is the effect of increasing the pressure on the equilibrium reaction above? Okay, so for a reaction in equilibrium like this, the only time you can observe the effect or you can see the effect of changes regarding pressure, okay, it is when the volume or the amount, okay, of the gaseous reactant is different from what you have in the product side. Okay, so if you study this, study the amount or the volume, you can see we just have 1 mole here for the gas. We also have 1 mole here. So you can see they have equal amounts. So definitely there will be no difference, okay, in changes regarding pressure. So even if we are talking about effect of increasing or decreasing the pressure, what you are still going to notice is that there is no effect. So the correct option is option C. 29. The equilibrium of an endothermic reaction which proceeds with an increase in volume can be shifted in the reverse direction by what? Okay, so basically we are looking at this is forward reaction. So we are asked, how can we bring this reaction to the left side? No, this is right forward then. We are taking it back. Okay, so we are looking at this endothermic reaction. So for endothermic reaction, the way you can reverse it or bring it back to the left or the reactant side is by increasing the pressure, all right, and decreasing temperature. So if you understand the metrics around endothermic reaction, so you should know that your correct option lies with option C, decreasing the temperature and increasing the pressure. So option C is the correct option. 30. The oxidation of ammonia in excess air produces what? Okay, so we have to be very careful here. All right, so we know that ammonia does not burn in air. Okay, but readily, yes, in oxygen, what you are going to get is a kind of a greenish yellow flame. All right, and that will produce water and nitrogen, water vapor and nitrogen. However, based on the options provided here, I want to say that probably a catalyst is involved here based on the provision of the options. So in the presence of a catalyst, right, what you should have as your products, there will be nitrogen 2 oxide, right, and water at room temperature. So based on the option provided, I just want to say that there's a catalyst, right, involved. So what you should get is this and water at room temperature. But where a catalyst is not involved, right, ammonia bonds in oxygen to give you water vapor and nitrogen. All right, so in air. Okay, so the correct option here, okay, based on the provisions we have, so option A is good to go. 31. Hydrogen sulfide gas can act as a precipitating agent and a reducing agent, okay? These abilities, precipitating ability, reducing ability, you know, they are very good checks when it comes to qualitative analysis. You know, the precipitating ability, you know, you want to dictate the metal ions present in an unknown substance, or the reducing ability when you want to test for oxidizing agents. So hydrogen sulfide gas can act as a precipitating agent. So option D is the correct option. 32. The gasification of coke is used for the manufacturing of what? Okay, so when you talk about gasification of solid feedstock, like your coal, like your petroleum coke, all right, so what is a very efficient process, you know, in getting synthetic gas. Okay, this is very useful when it comes to combustion turbines or gas turbines. You know, these gas turbines, they are essential when you want to power, you know, probably an aircraft, a ship, a train, or even so many examples like that. Okay, so the gasification of coke is used for the manufacturing, in short, a very efficient process for the manufacturing of synthetic gas. So option C is the correct option. 33. The gas that is most useful in protecting humans against solar radiation is ozone. So the ozone is actually a triatomic molecule, an allotrope of oxygen. So we have 3 molecules here. 3 atoms here rather, O3. Okay, this is very useful. You know, the depletion of the ozone has led to several effects that we are now seeing here. Okay, all right, so the correct option is option B for ozone. 34. Which of the following allotrope of carbon is a constituent of lead pencil? Okay, so when you talk about the allotropes of carbon, we have the crystalline allotropes, okay, like your graphite and diamond. Then we have the non-crystalline, okay, like your charcoal, your coal, your coke. All right, so when we talk about diamond, you know, you can find it in places like Africa, naturally in Africa, okay, Brazil as well. All right, we can use diamond when it comes to mining tools and all those drilling tools. It's very, very hard. Okay, then let's talk about graphite. You know, graphite is a very good conductor of electricity. You know, it's also very good as a dry lubricant. Yes, excellent dry lubricant. And also it is, you know, when you mix it with clay, it is very useful when it comes to lead pencil. So the correct option is option A for graphite. 35. Which of the following metals will show the highest metallic character? Okay, so we can use the reactivity series or the activity series. Okay, so when you look at the arrangement, okay, you should take note of this. The metallic character actually increases down the group. All right, so naturally what you would tend towards, you know, you are going to arrange it from, you know, potassium, sodium, calcium, and the likes. Okay, but correctly, since we have calcium and barium, right, in the same group, so down the group, you should know that barium is more metallic compared to calcium. All right, so the correct option here is option C, barium. You know, naturally we just say, oh, calcium, but no, when you check the metallic character down the group under that phenomenon, we are going to select barium. So barium is good to go. 36. Copper metal dissolves in conc HNO3 acid with the resultant evolution of what? Okay, so pure HNO3, okay, we react with this copper. All right, what you are going to get is the copper will get oxidized, and you are going to have copper 2 triosonate 5. Then the HNO3 acid itself will get reduced, okay, to NO2. nitrogen 4 oxide. We can also know this. We should note that this is a very strong oxidizing agent and a strong acid as well. Okay, so its reaction with metals is unlike other acids. All right, so let's go back to the question. So what you will get, the evolution of the gas that you should get is this, NO2. So option C is the right option. 37. The type of iron that is best suited for welding, making nails, chains, and iron rods is what? Okay, so pig iron, you know, this contains a considerable amount of impurity. Okay, it is hard, it is brittle, and it has limited industrial use. All right, so we have cast iron. We're talking about making items that does not really require high stress. Okay, so you can talk about your cooking stove, you know, your cookers, your stoves, and the likes. All right, let's come to wrought iron. This is the purest form of commercial iron available. It can be easily forged and welded, right? Making nails, chains, iron rods, and the like. So this is it. Iron pyrites, this is one of the common ores of iron. All right, so the correct option is option B for wrought iron. Please remember that you can have a JAMB CBT experience. All you just need to do is to click on the link in the description below. This is going to get you to the Myschool website. Right there, you get to download the Myschool mobile app for your Android devices, or you can check our Myschool software for your laptops and computers. So join me as I solve question 38. In the electrolytic extraction of aluminium, the function of the molten cryolite is to do what? Okay, so if you want to get pure aluminium, okay, that's through the process of electrolysis of alumina. All right, alumina, or you can say aluminium oxide, okay, which is dissolved in this. Okay, the function of this is actually to lower the temperature at which this electrolytic process will take place. So basically, you are talking about lowering the melting point of aluminium oxide, or alumina, if you want to refer to it that way. So usually this should have I think it should work around the melting point of about 2000 plus degrees. So, but the presence of this will allow the process to operate around 1000 degrees Celsius, thereabouts. Okay, so the correct option is option B. Please do not forget to always encourage us by hitting that like button. Also click on the subscribe button and always tap on bell notification for you to get alerts immediately we upload the next video content. 39. One of the products of a thermal decomposition of sodium triazonitrate 5 is what? So basically we know that the salts, all right, of the triazonitrate 5 salts of potassium, sodium, you know, they decompose on heating to give you their dioxonitrate 3. Okay, so in this case we are talking about sodium. So what I'm going to have will be sodium dioxonitrate 3 and oxygen. All right, so this reveals the affinity of alkali metals for oxygen. All right, so the products we should get is this sodium dioxonitrate 3 and oxygen. So oxygen is not here, so we just stick with the one provided. So option C is the correct option. 40. A cracking process in petroleum refining can be represented by what? Okay, so you know cracking, you are breaking down heavy molecules or larger molecules to smaller molecules, heavy molecules to lighter molecules. All right, heavy oil to light oil. All right, so right here I think the case study is heptane. So once you crack heptane, what you should get is propene, right, and butane. Of course, you know this is the alkene group that you get from there. Then we have the butane. So the correct option is option C for heptane to propene and butane. 41. Which of the following molecules has two other positional isomers? Okay, so isomerism, you know, you refer to same molecular formula but different molecular structure. So you know we have the concept of structural isomers. Then underneath we have this positional isomers. Okay, so right here we are looking at alloalkanes. All right, for mono alloalkanes, that is just one halogen group there, one halogen member present there, that is mono alloalkane. So for a mono alloalkane to exhibit positional isomerism or generally structural isomerism, there must be at least 3 carbon atoms. So let's scan through. So this is already cut off. We just have 2 carbon atoms, so it is out. So let's look at option B. We have 1, 2, 3. Okay, this is qualified. Then let's look at this. This is gone. Okay, this is for dialloacanes. Okay, there must be at least 2 carbon atoms. So this is struck. Okay. Then let's look at this. We have 1, 2, 3. So, and we have 2 halogen members, isn't it? So this is qualified for dialloacanes. This is qualified for monoalloacanes. So at least 3 carbon atoms. So let's try and identify this particular compound. I have 1, 2, 3. That is C3. How many hydrogen? We have 3. We have plus 1. That is 4. Plus 3. That is 7. So I have C3H7, right? Br. All right. So that is 1 bromopropane. Okay, there are 2 positional isomers to this particular compound. 1 bromopropane or 2 bromopropane. That is 2 positional isomers. So let's see the context between this particular option B and option D. So this is 1, 2, 3. That is C3. I have 2 hydrogen plus 1. That is 3 plus 2. That is 5. Then I have 2 halogen family. Okay, so I would have identified this properly as a dialloacane if I had C3H6. Do we see that? C3H6. Then I can point out that this should have positional isomers of about, 4. Yes, 4. I should be able to identify 4 isomers to this. Okay, so this is disqualified. All right, so the most viable option here is, you can see the arrangement just to start with you a little. So this is the correct option. Okay, so we have C3H7Br. Okay, this is the isomer. Okay, the molecule with 2 positional isomers. So the correct option is option B. 42. Which of the following class of compounds can exist as dipolar ions in solution? Amino acid. No, these are basic structural units of building blocks of proteins. Okay, so examples of amino acid, you can refer to your alanine, your phenylalanine, your cysteine, your glycine, and the likes. Okay, so we know that amino acid can exist in neutral solution as this dipolar ions, and you can refer to this as Zwitter ions. So the correct option is option D for amino acids. Question 43. Lucas reagent is used to test for what? Okay, so we are referring to alkanols. Okay, so we have 3 classes. We have the primary class, we have the secondary, and the tertiary. So the role of the Lucas reagent is to actually help us to distinguish what type or what class of alkanols that we are trying to observe. Okay, so if you check the reactions or the observations, you realize that for tertiary alkanols, you will notice immediate turbidity. Coming to secondary alkanols, you will notice turbidity after some time, probably like 5 minutes or more. All right, then for primary alkanols, no visible reaction. So the Lucas reagent is used to test or distinguish the classes of alkanols. So option C is the correct option. Number 44. A compound commonly used for sterilization and preservation of specimens and food is ethanol. Okay, so for ethanol, we can also use it for flavoring. Also serve as solvent. Several uses. You want to make methylated spirits, your alcoholic beverage. We point to this. Then let's come to benzene. Okay. Benzene is very necessary. It's required when you want to make nylons, you want to make pesticides and the likes. Okay, then let's come to ether. So for ether, the uses, it can be used as a cooling agent, also as solvent. All right, then ammonia. Ammonia is required, in laundry. You want to make fertilizers, of course, and it's also used when it comes to refrigerants. Okay, so the correct option from what we've shared, that's option A for ethanol to put. 45. An organic compound reacted with bromine water to give a colorless solution. So the compound is probably an alkene, okay, or alkene, or alkyne to put, okay, alkyne or alkene. Alkyne, with the spelling Alkyne, alkyne, you know. This is one typical lab test, okay, for unsaturated compounds, okay, like alkene and alkyne. All right, so right here, these compounds, they will decolorize the bromine water from brown solution, some will say brown solution, reddish brown, from that color to colorless. As well, you can use acidified solution of KMNO4. Okay, it's going to change from purple immediately when it comes to alkene. It's going to change from purple to colorless. All right, but we can't generally accept KMNO4, okay, because reducing agent too can do the same thing to KMNO4. So it is safe or safer to stick to this, okay, the bromine water. So an organic compound reacted with bromine water to give a colorless solution, the compound is probably an alkene or alkyne. So option A is the most appropriate option. Question 46. Which of the following hydrocarbons is mainly used as fuel? So take note of this, mainly used. So this I can point to methylene blue. Okay, it's very useful in medicine. This is ethylene. This is the old name for ethene. You know, when you talk about manufacturing plastics or, you know, fruit ripening, right here. So methane, this is mainly used as fuel, either by itself or you mix it with other gases, mainly used. Okay, then we have ethane. So ethane here, you know, is sometimes used as fuel in all these miners' lamp, you know, people that are into mining, so their lamp, you can use that as fuel. So this is sometimes, this is mainly. So the correct option is option C for methane. 47. The molecular formula of a common organic laboratory anesthetic is what? This is trichloromethane or chloroform. You know, this is very useful. Then, late 19th and early 20th century, it was used as inhaled anesthetic during surgery, but because of its toxicity, you know, so it has been replaced, nowadays has been replaced with safer anesthetic. All right, it can also be used as solvents, you know, when you want to produce pesticide, it's very important. Okay, so then we have this. This is tetrachloromethane. This is also an important organic solvent. Okay, so back to the question. So we are asked the molecular formula of a common organic laboratory anesthetic as a den, okay, is this chloroform or trichloromethane. So option A is the correct option. Asking your question is completely easy. All you just need to do is to click on the link in the description below. This is going to get you to the Myschool website. Right there, you get to ask your questions, and our solution providers are willing and ready to help you out. So join me as I solve question 48. The simplest branched chain hydrocarbon is what? Okay, so for alkanes to be able to exhibit structural isomerism, they must have at least 4 carbon atoms. So the 4 carbon atom, that is butane. Okay, so the structural isomers of butane, they are actually 2. We just have 2 isomers. Okay, so that is the normal method, that is N-butane, and 2-methylpropane. So the correct answer is option D for butane. It is very possible that you have better explanations to offer. Please, we are so much interested. All you just need to do is to please use the comment section below. Kindly indicate the question number and the explanations or reviews you'd like to share. Number 49. Organic molecules that have the suffix ENE are unsaturated hydrocarbons that have what? Double bond, double covalent bond between adjacent carbon atoms. So a single bond hydrocarbon, you're talking about alkanes. All right. A double bond hydrocarbon, you're talking about alkenes. Okay, with the formula CnH2n. Alkanes formula will be CnH2n plus 2. All right, triple bond that is for alkyne. All right, KYNE. This is KANE. All right, so for this alkyne, the formula is CnH2n minus 2. All right, so the correct option here is option B, double bond alkanes. This is the suffix for it. All right, so option B is super correct. Question 50. If the relative atomic mass of an element is not a whole number, okay, so it can be deduced that the element is an isotopic mixture. This is very correct. If you look at the concept of isotope, you know we are talking about atoms of the same element, all right? They have the same atomic or proton number, but different mass number. You can say different neutron number, okay? So, you know, when you now bring together these isotopic masses, okay, so like for instance, if you look at elements like your chlorine, you can see that the atomic mass or the relative atomic mass to put is actually 35.5. Okay, so that means it tells you that the isotope, all right, when you take the mean or the average of the isotopic masses of each chlorine atom, you will notice that it will not give you a number. So this concept reveals that isotopes are involved. Okay, other examples of elements that are exhibit isotopy: carbon, hydrogen, oxygen, and the likes. So the correct option here is option D, an isotopic mixture. So we've come to the end of this video lesson, but there are definitely wonderful content to come. All you just need to do is to always hit that like button to encourage us. Also, do not forget to click on the subscribe button and always tap on bell notification for you to get alerts immediately we upload the next video content just for you.